Hello, this is Vince, and I'm here to talk about Hex Star Battle. So this is a tool that I built just for my own use, but you're welcome to use it if you want. It's at benjofel.github.io/starbattle.html, and here you can build your own star battles. Obviously, you can use Penpa, and probably should use Penpa for distributing these, but I built in a solver, a brute force solver, that can tell you whether you have 1 or 0 or even multiple solutions to your star battle once it's in place. So let's take a look. You've got undo, redo, clear shading, save changes. So once I make some changes here, I can save them to a new tab. Solve mode, toggle between solve and edit mode, and then changing the solve colors and border width. So edit mode is the most interesting here. You can see it's very colorful. So each of these colors is a different region, or rather each contiguous group of colored cells is the same color as one region. So these are two different orange regions, and they'll just show up with just the border once you get to solve mode. So I can solve using left mouse to unshade, I'm sorry, right mouse to unshade, left mouse to click. So if this was a star, it would look like that. Now I'm using shading instead of stars just because that's what was easy to code, but this means this is a star and these ones aren't. Okay. Now in edit mode, if you want to change the region shape, you just select whatever color you want and start drawing, and that'll change the shape of your region. So now this blue region is bigger, the green region is smaller. Now it's even bigger, and now this yellow becomes two different regions. Obviously, that's not going to work for Star Battle. You need exactly the same number of regions as you have, lines. Oh, I also joined the blue regions, so actually this might work. Anyway, the more interesting thing, let's go ahead and undo that. The more interesting thing is the brute force solver. Oh yeah, here we can change the board size to whatever size we want. The number here, in this case 6, is the number of cells on each side, or conversely, the radius of the hexagon. Let's go back. So here's a partially clued grid. You can see all the regions are in place, but only some of the stars have been penciled in. So if I go here and I click to find a solution, and I put in 2 stars, because that's the type of star battle we're solving here, it finds a solution. If I do a control click, let's do a control click. Shift click would just do some automatic unshading for you if there's 2 stars in the line. But control click is going to find all the possible solutions, which, because this is a unique grid, there's only going to be one. You'll notice that this, there we go, one solution. You'll notice that this help text stays in place, and in fact the entire screen freezes while it searches for a solution. This is written in JavaScript, so it is fairly slow. I'm actually working on a WebAssembly version, which is going to be much faster, hopefully, soon. But for now, the JavaScript version can hopefully help you if you need it. So JavaScript is quite slow, but it works on grids, especially size 7 and below. If it's partially clued, should be able to tell you if you have at least find a solution for you to know that there's at least one solution left. So if I wanted to show something else, if you hit Shift while you draw, you're going to be removing those colored cells. Okay. So now, if I cleared shading, you'd see this is all white. So this part has not been associated with regions yet. And I can still do solving. It won't do a check on the number of stars in that region because there is no region, but it'll still use stars in the rows and columns to prove out logically what the possibilities are. So if I undo to get my partial stars in again, I control click here, put in a 2. It's going to identify there are exactly 2 solutions to this setup, given all the constraints, rows, columns, or rather lines in all 3 axes, and then also to satisfy the conditions of the regions. So exactly two solutions, and you can see it fills in everything except those possible placements where the stars could either be here or here. Okay, I hope this was helpful. Please let me know if you have any questions. Thank you. Bye.